How y'all doing?
Good.
Good? Did y'all have a good break?
Yes, sir.
Yeah? Good. The last time we met, we covered rational functions. The video did not record. Yeah, I know. It's weird because the last time we met was the 10th. And I uploaded a video like before spring break that said the 10th, March 10th. But it's the video from the 8th. So I'm not sure what happened to the video. It's not on the SD card. It's gone. So what I'll do is I'll make sure today that I go through a rational function graphing. That way we have that on video, and then we'll get into exponential functions. What did I ask y'all to do? Did I ask you to do anything over the break?
The questions.
The
two other questions.
the two others, yeah.
The A and B.
Yeah. So I don't know. Maybe do you think it'll be worth it just to go through those?
Yes. Yes, please.
Yeah. Okay. I think we'll just do that. Yeah. Just at the end, you can just turn in what you have. Okay. Because the video kind of, yeah. I think I deleted it thinking, oh, three tens uploaded already. I must have done it. I forgot, and I think I may have deleted it, but okay. We still have. Well, it's 11, right? So we can get started. So a couple of things. Next Thursday, exam 3. That's the schedule. That's the 31st, and I might have something that morning. Actually, I think about it, it's at 10 o'clock. So there's a chance that either we move this exam or we do something. I wouldn't move it earlier, but we might have to push it to the next week because I might have a conflict with class on that Thursday. So just this right now is kind of tentative. That's the plan. We'll see how things go. Otherwise, that's the layout of what we're going to do, all right? So let's start class off with going over those problems I asked you to do for extra credit. Let's do this. If you have it now, if you tried them, why don't you turn those in, all right? And that way I can give you credit for trying, and then you can just copy down what I have here, and you'll have another copy of it. So that sound okay? If you have something, go ahead and I'll just take it. Make sure your name's on it. Anyone else? Okay. Both? Okay. Thank you. Anybody else? That's it? Okay, so I'm gonna do these now, all right? Because I think it's worth it. This is going to be a big part of your next test. So the first one I asked you to graph was x plus 1 over x squared minus 4x. Let me put on here bonus. It was what, 5 points, right? Okay, so that's the first one. So let's go through the steps, all right? So the first thing, we want to find the x-intercepts, right? So first step, find the x-intercepts. So to do that, all you do is you set the numerator equal to 0 and solve this. And just subtract 1 on both sides, you get x is negative 1. Now, the thing to remember is that when you have an x-intercept, this is actually a point on the graph, right? This is an actual point on the graph. You could say it's a point on the x-axis, if you like. Okay, so that's going to be actually part of our graph. The next thing to do is to find the vertical asymptotes. You may have 1, 2, you may have none. And to do that, what do? To find your verticals? Set the denominator equal to 0. So you set this equal to 0. And here, we're going to have to try and solve that equation. So can anyone share how they would go about that?
I broke it down.
What do you mean?
I forget what it's called, but I did the X.
Okay, GCF, greatest common factor. So you notice that these both have an X, so you factor an X out of both of them. So you get this. And then once you do that, you can set each of those factors equal to 0. So you set this to 0, and you set x minus 4 to 0. This is just, that's your answer, x is 0. And then over here, you add 4 to both sides, and you get 4. All right, these are not like technically part of your graph. Like this is a point on your graph. These aren't points on the graph. These actually are your vertical asymptotes. So these are those vertical dotted lines. Okay, these are the vertical dotted lines. And what those things do is, remember, when we draw them on our graph, the function, when we're drawing it, can't cross through it. So it has to be forced, the graph gets forced up or down when we get to these. All right? All right, so that's the second thing. The third thing is to find the horizontal asymptotes. Okay, to do that, what we're going to do is we're going to go look at the degree of the numerator. So here the degree of the numerator is 1, right? And the degree of the denominator is 2. And you compare those. And when you compare two numbers, you have only 3 possibilities. Either this one on top is bigger than this one is smaller than this, or they're the same numbers. And in this case, the degree of the numerator is smaller than the denominator. And I told you all, do you have that? I know you write down stuff. There's 3 cases, so this would be case A from our notes, right? This would be case A, because the degree of the numerator, 1, is less than the denominator. And in this case, the result is that the x-axis is your horizontal asymptote. So you'll have to remember on the test coming up next week that there are 3 possibilities here of what could happen. This is one of the possibilities where the x-axis is the horizontal asymptote. Okay. Now let's go ahead and let's talk about what this is. Again, this is not part of the graph. It helps us draw the graph, but it's not actually technically part of it. This is going to be a horizontal dotted line, edges only. Right, I told you only draw it at the edges. And it acts like a magnet. I told you, that's the way I like to look at it. It acts like a magnet. It kind of pulls your graph towards it as you draw out to the edges. Okay, so now what I'm going to do, the 4th step, is to just do a sketch. Right? I'm going to do a quick plot of everything I have here. So this will be kind of my picture. Let's see. See how this goes. I'm trying to squeeze it in right here. So first thing I know is that, see if this red marker works. Good enough. All right, so I know that I actually have a point on the graph at -1. So I'm going to go to -1 on the x-axis. My graph is in red. Okay, there we go. Then I have vertical asymptotes, 2 of them, one at 0 and one at 4. So what am I going to draw?
Dotted lines.
Dotted line, vertical, right? So let me see, 4, this one's probably easier. I'll just go to 4 here. Draw a vertical dotted line, like this. And then I have another one at 0, which is the y-axis. So I think I told you all just to kind of draw these little diagonal dashes so you know it's there, and then up here you can continue it up and down. So I have 2 vertical asymptotes. They're in purple. It's hard to see that that's purple. Okay, and then I have a horizontal asymptote. That's a horizontal dotted line. I'm only going to draw it at the edges, and it's the x-axis. So that's going to be out this way. I'm going to go off camera here, so I'm going to just do this. Comes this way, and then over here goes like that. Okay, so that's what I have so far. Now, what's next? What do we do now?
Do the test points.
Test points, right? And do you remember what I told you as far as what you can do to determine how many test points you're going to need?
One more test point than the x-intercepts and vertical asymptotes combined.
Exactly. So however many x-intercepts we have, plus however many verticals we have, one more than that. Okay, so we have one of these, we have two of these, so that's three, so we should need 4 test points. We don't look at horizontals for test points. It's only the verticals and the x-intercepts. So we have 1, 2, 3. I'm going to need 4 test points. So when I'm looking for them, you're always going to need one on each edge. So I'm going to need something over here, any number I want, right? Any number. So I'm going to pick any number to the left of -1. So I'll pick -2. And then, this one's going to suck. I need one between these two. See, here's a vertical, here's my x-intercept. I need something between these two. So unfortunately, I'm going to have to pick a decimal, like -0.5. And then over here, I'll need any number between here and here, so 1. And then over here, any number I want, so how about 5? Notice when I was picking my test points, when I picked them on the x-axis, I put little x's and not dots, just because I don't want to, later when I'm drawing the graph, I don't want to accidentally think that these are part of my graph. This is just to represent where I'm picking them, all right? And now what do we do with these test points once we have them?
Plug them into the function.
Plug them into the original function right here. We got to plug them in and see what we get when we plug them in there. So we're going to have to plug in 4 numbers into that function. Let's start with -2. So if I plug -2 into this for x, I get -2 plus 1 on top. I get -2, I've got to square it, and then -4 times -2. The top is -1. When I square -2, I get +4. And these two negatives multiply together to become positive, right? So this is a +8. So 4 plus 8, 12 on the bottom. Now you may or may not remember this. I know spring break, I mean, it's been a long time, but really the only thing I'm really concerned about here is whether or not this is a positive or a negative number. And it's negative, right? Which means that when I go to actually plug -2 into my graph, right, into my function, it spits out a negative number, which means the point is down below this. Not above, but below. Where you put it doesn't really matter. I mean, -1/12 is a really small number, but just put it below the x-axis. That's all that's important, is that it's down. So now I continue, right? I'm going to get my next one. This next one, -0.5. That one's going to suck, okay? -0.5 plus 1 on top. Then I have to do -0.5 squared minus 4 times -0.5. Okay, so yeah, you might need your calculator here, okay? So if you take -0.5 and add 1, you'll get +0.5. If you square -0.5, you get 0.25. And then 2 negatives multiplied together here to be a positive, so it becomes plus, and these two multiply together to give you 2. So just looking at that, is that a positive or a negative number at the end of the day here? Positive, right? I have positive on top. These two add up, that's positive. So positive divided by positive, it's positive. It's all I really care about. So that means over here on my graph, at -0.5, I'm going to put a dot above. And again, doesn't matter where. I'm just going to just kind of squeeze it in here. There you go. And then I have to do the same thing for the remaining 2 points, right? I have to plug in 1, then I have to plug in 5. Are there any questions? So when I plug in 1 and plug in 5, I'm not going to go through the work on these. I'm just going to tell you what happens. This one comes out to be negative, and this one comes out to be positive, all right? I'm not going to show the work. Is that all right that I don't show it? Everyone? Now, students will sometimes ask me, they'll see a pattern. They'll see, hey, this was negative, then positive, then negative, then positive, like it switched. So why not just find the first one and then just assume that all the others switch? Unfortunately, it doesn't have to do that. Sometimes it can go negative, negative, positive, positive, or negative, positive, positive, negative. So you have to check each one, unfortunately. Okay, All right, so here we go. At 1, it's going to be negative, so I'm just going to put a point down. And then at 5, it's positive. I put a point up. We're almost there. Almost there. In theory, we have everything we need now. We should be able to draw the picture. So I like to start at the leftmost point that I know exists on my graph, which is this. I start drawing this way. And when I do that, I see the magnet. And the magnet tells me I get pulled up towards it. So I'm just going to just pull it up there like that. That's it. From the same dot to the right, I notice I've got to connect to here and then to here, right? So I just connect these together. And then when I'm at this dot, trying to move to the right, I see my vertical barrier, right? And that vertical barrier is going to force my function to either go up or down. And I think we talked about this. Which way does it go, up or down? Up. Yeah, it can't go down. If it comes down, it's going to cross the x-axis. And you're only allowed to cross here. So you would create an x-intercept if you went down, and that means you have to go up. So it goes up and just kind of gets closer and closer to that, never actually touches it. It's a weird behavior, but that's the way rational functions behave, all right, at vertical asymptotes. Once we're there, we finish that off, then we come over here and we look at this point, and we do the same thing, draw to the left and to the right. So if I draw to the left, there's my barrier again, right? So I have to either turn up or go down. And again, I can't go up because I can't cross here. So I have to go down. And then what about if I draw to the right? Same thing. It's got to turn back down again. It can't go up. Can't cross the x-axis. So it's weird. It's like a little U upside down. It's not a parabola. Technically, it's not a parabola, because it stays between these two like walls. Parabolas spread out as you go. So it looks kind of like parabola, but it's not. And then I go to this point, I draw to the left, and I'm going to have to go up because the barrier can't go down, can't cross here. So I'm going to go up over here. And then here to the right, there's my dotted line. I get pulled down towards it. There it is. Questions? How's the first one? All right. So the next one is that same function flipped over, right? That was the next one I asked you to look at. If you take f of x, and this time do the x squared minus 4x on top, and the x plus 1 on the bottom, if I ask you to graph this, what does that look like compared to this one, right? This is the graph of that flipped over. Now, let's see what that does. So, same set of steps. First step, x-intercepts. We set the top equal to 0, right? The top. So, we've done this already, haven't we? I mean, we did this in the previous problem. We did it right here, didn't we? So, we should have the same solutions. But what they represent on our picture is different, right? Because these are the x-intercepts, not the verticals. So I factor out an x, set each one of these equal to 0, get my two solutions, 0 and 4, right? But these are points on the x-axis. They're part of my graph, right? They're points on the x-axis because they're x-intercepts. When I go to step 2, for the vertical asymptotes, now I set the denominator equal to 0, right? So I set the x plus 1 equal to 0. And I get x is negative 1. Do y'all see that this problem, the only thing that's happened so far is that the verticals and the x-intercepts have switched places with one another, right? So this is going to be a dotted barrier. My graph can't cross it. Okay, what about the third step, the horizontal? Okay, so for the horizontal, this time the degree of the numerator is 2 and the denominator is 1. So we have that 2 is bigger than 1. Thanks, Ray. Yeah, so this is case B. Look in your notes from last time. Case B, we have no horizontal asymptotes in this case. So what does that mean? What does it mean that we don't have any horizontal asymptotes? It means that we don't flatten out, okay? There's no magnet pulling our graph down, which means that the left side is either going to go up or it's going to go down, kind of like a polynomial. Remember the polynomials? We had that table, that chart that we use for left and right behavior. It's kind of like that, but we don't know which of these two it is. And then on the right side, it's going to go up or down, but we won't know, okay? And in the middle, we'll figure out what the middle looks like. But that's what case B tells us. We don't flatten, so we go up or we go down forever. Any questions? Fourth step. Let's get a picture. I want to leave this one up here because I want you to see them side by side and see how different they are. Okay, so here we go. Start with the x-intercepts. I have two x-intercepts. They're at 0 and at 4. So I have an x-intercept here at 0. I have an x-intercept here at 4. I have a vertical asymptote at -1. Like that. See, it already looks different than this, right? I only had 1 point that hit the x-axis. Here I have 2. Here I had 2 verticals. Here I only have 1. Good? No horizontals. So I'm not going to draw any dotted lines this way at all. I'm just going to leave it like this. That's all I have. So let's get our test points now. How many will we have?
4 still.
We'll still have 4, right? Test points. And for my test points, I can use the same ones, can't I? I can use the same ones. I can use -2. I could use -0.5. I could use 1. And I could use 5. But here's the thing. We don't get the same result as we did last time necessarily. Or do we? Do we get the same result? You won't get the same number, but will it still be like the same in terms of positive and negative? Yeah, it should, because isn't it, like if I flip this over, right, doesn't change the sign, does it? If it was positive and you flip it, it's still positive. If it's negative and you flip it, it's still negative. So because of that, on this particular example, I don't need to plug all these in. I'm just going to write down what would happen, though. If you plug in -2, plug in -0.5, plug in 1, plug in 5. I'll plug in one of these. How about that? I'll plug in 5. All right, so if I plug in 5 up there, I get 5 squared, that's 25, minus 4 times 5 is 20, over 5 plus 1, which is 6. So that's going to turn out to be positive. All right, I'm not showing it. I'm just kind of like quickly plugging it into the function. So that's positive. Without me showing the work, this one's negative, this one's positive, this one's negative. We okay with me not showing that? All right, so let's plug in. When we plug in -2, we get a negative number. So when I go -2, I go down. I'll put it here. When I'm at -0.5, I'm positive, so I'm going to put a point up. When I'm at 1, I'm negative. I'm going to come down. And then when I'm at 5, I'm positive. I'm going to come up right here. There we go. This should be everything we need to draw the picture. May I continue? Yeah. From this point to the left, I don't have a magnet, do I? I'm not supposed to flatten out. So I'm supposed to go up or down. Which way is it? Am I going to go up or am I going to go down? Down. Why not up? You'll cross the x-axis. And you can only cross here and here. So it's got to go down here. So to the left, I'm going to draw it like this. going down. What about to the right? Got a barrier, right? So it's going to have to turn down, right? Can't go up, can't go up, can't cross up here. So I'm just going to turn it down like this. Okay, once I get to this vertical, I kind of jump over it, grab the first point I see, which is this one. Remember, you have to draw it to the left, but there's the barrier, so what? Up, right? Can't come down here. Can't come down, you gotta go up. So it's gonna go up here, that. And then check this out, we're gonna be in kindergarten now. I'm just gonna connect all these dots together. See, there's no barriers in my way, right? So I'm just going to connect, 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 connect. With kind of something that's curvy, I guess, like this. There we go. And then once we get to this far right point, where are we going? Yeah, we've got to go up or down, right? And can't go down because you'll cross the x-axis. So that means this thing's just going to go up. There we go. Look at the difference between those two graphs, right? All we did was flip them over, right? And it had a huge impact on what the picture looks like. How do y'all feel about this? Better? A little better? What part of it do you think is the tricky part? Is it putting all the dots together? Are you more concerned about like the factoring? Any part of it that?
No, I was getting lost in the like whether to go up or down.
Do you understand why?
Yeah, I understand.
Okay.
I get it.
So remember that whenever you draw a function, okay, all functions must pass the vertical line test, which means that once you're done drawing it, if you take any vertical line, you should never hit your graph more than one time. So see, I'm hitting it once. No matter where I am, I'm only hitting it one time on both of these, right? That's what makes a function, is when that happens. The reason I'm saying that is because people will do weird shit when they draw these things. And I don't know, I mean, let's just say someone drew this. I don't know, I'm just gonna do it like that right there. Let's just say they did that. Okay, you should know right now, when you take a step back, you should know this is wrong. I mean, not only because you missed the vertical, but look, you failed the vertical line test. See, I'm hitting it twice now, right? I'm hitting it here and here. So it's not a function. And that's why when we were at this point where we said we had to draw to the right, you have to go up or down, you can't turn back. Like, you can't do anything weird where you turn away from it, because then you're going to fail the vertical line test, you see? I hope that makes sense. Okay. Let's do one more, okay? One more. And then we'll have a chance on Tuesday when we do the review for the test, we'll have a chance to revisit this a little bit, maybe do one more then. But let's do something a little more challenging, all right? Today is my halfway point of, remember I told y'all I was working out 12 weeks, right? Today is week 6. Week 6 is over. So it's been 6 weeks. 6 more weeks to go. I'm getting a little burned out though, I can tell you that right now. Get on with 43 days or something like that in a row. Okay. Hold on, I want to make sure this works. There we go. Let's sketch this. All right, it is a rational function because you have a polynomial on top. Actually, it's a quadratic, but all quadratics are polynomials. Polynomial on top, polynomial on the bottom. So the first step is to find the x-intercepts, right? All right, so how do we find the x-intercepts? You set something to 0. What do you set? Numerator. Okay, so set the top to 0. Okay, 3x squared minus 4x minus 21 equals 0. Now, this problem, the reason I'm giving this to you is because this is the first problem where we have some, I guess the factoring is not simple. All right, we have to do a little bit here. Okay, so, oh shoot, you know what? I messed up. Sorry, this is supposed to be a 7. Sorry. That wasn't going to work. 7, 7. Y'all change it? 7 there, 7 there. Okay, so we need to solve this equation. We can't factor out an x, right? No GCF. They don't all have an x in them. So you have two options on how to solve this. Option 1, factor using that kind of like, look at the number in front, look at the number back. Remember that game that we played? Yes? Okay, we can do that. Or if that fails, you always have the quadratic formula, right? Those are your two options. So I'm going to do it, well, how do you want me to do it? You want me to do it both ways? You want me to do it? Let me just do it both ways. Let's do the factoring first. If I were to do the factoring, what I would do is I'd multiply, let's do it over here. This is going to be like scratch work I'm going to do on the side. Okay, I'm trying to factor out 3x squared minus 4x minus 7. I'm just trying to factor this. So I multiply the 3 times negative 7, that gives me negative 21. And then I look at the number right there, negative 4. Oh, negative 4. Right? And I need to find two numbers that multiply to be this, but add up to be this. So can you think of two numbers that multiply to be negative 21?
Negative 7 and 3.
Negative 7 and positive 3. Those are the numbers, right? If you multiply these two together, you get this. If you add these two together, you get that. Now, see if y'all remember what I said to do here. Set of parentheses. These two numbers, right? Minus 7 plus 3. An x with a space in front of it, an x with a space in front of it. And then there's this very critical next step. What do I have to do? Remember, this is the 3, not a 1. So I've got to put the 3 in front of this and under this, or the other way around, in front of this and underneath this. So which way do you want it? Do you want the 3 here and under here, or the other way?